Hello viewers, welcome to the class for today. It's year 11 recalculus and we want to look at simplifying radicals. We'll be starting with this question on the board. My student who join the class right now, you can subscribe to this channel. Thank you. How are you today?
Yes, I'm good.
Alright, you're welcome to the class for today. So we're still working on simplifying radicals and we have this question on the board. It says, is square root of x squared, is it equal to x? And they want us to answer yes or no. Can you hear me clearly?
Yes, I can.
Okay. So they want us to answer yes or no, but the answer will depend on certain factors, because we could easily say maybe if we cancel this, then it's going to be yes, but the answer we can't conclude yet until we've like verify for all the values of x. Maybe if x is -1, then the expression is going to change to something like let's see, it will change to -1 all squared. And based on this, if we follow the first step that we did, like canceling the root and whatever, then we can cancel this. Then we will try to say maybe it's going to give us -1, which is not really correct. So we can go ahead and say, what is -1 squared? That is -1 times -1, and that'll be 1. And square root of 1 will be 1. So this is wrong and this is correct. In as much as it does not give us what's in the the radicand we have, it doesn't give us this. Then this is the answer is no. So we cannot just say that the square. So what we can deduce here is that the root we have here is even, which is 2. So when the root is even and the answer is having index of, one odd index like 1, 3, 5, and so on, then we have to go for positive value, because this will be the absolute value. The absolute value of -1 will be 1. So when we have even roots, which is which produces let's say when even roots produces odd index, then we must have absolute value. Absolute value. Is that clear?
Yes.
So that means instead of saying root of x squared equals to x, then we can say it's equal to absolute value of x. So with that, even if x is negative, it's going to cater for whatever is under the root. So to further explain that, we can say if x is greater than 1, like we have absolute value x, so we can have x greater than 1, we can have x greater than 0 or equal to 0, we can have x less than 0. So if x is greater than 0 or equal to 0, it's going to be positive when we even square it. And if it's less than 0, also it's going to be positive when we square it. For example, if x is greater than or equal to 0. Then from here we have our x, which when we square x, we still have our x squared. Then if it's less than 0, like x less than 0, then we have the negative number. Then if we square a negative number, so it's going to still give us this positive. Is that clear?
Yes.
Okay. So let's say we want to move out into something, some other kind of questions. Like to simplify the first one, we have root 16. And since this is a perfect square, we know that this is 4 times 4. And root 4 is 2, root 4 is 2. So 2 times 2 is 4. So the answer is this. If we have the second one like root 32, we look for perfect square in 32, which is 16 times 2. Since root 16 is 4, we could say plus or minus 4, but it doesn't matter for now. So we use the principal root. So here we have 4 root 2. Is that clear? Is that clear? Can you hear me? Oh, you are muted just in case you don't know.
Okay, sorry. That's my sister that quote.
Alright, no problem. So the other one is 3, 4, 3. In this, we also look for perfect square, which is 49, then times 3. So square root of 49 is 7. We have 7 root 3. Then there is another question here. 5 root 54. So in 54, we're going to look for perfect square. So we get, can we actually get a perfect square in 54? Is it possible?
For 54, no. I don't think so. It's not
I
perfect
think
square.
we can. Maybe 9, right?
Square root of 9, I thought that was 81.
9 times, no. Square root of 81 is 9, right? But square root of 9 will be 3, right?
Oh, yeah.
So 9 times 6 is 54. So we can get 3 from the 9, so that will be 5 times 3, root 6. And this will be what? 15 root 6. We can't split 6 further, so. Then the next one, we have, let's say 4 over root 2. So whenever we see this, we are rationalizing. So this could be 4 over root 2, then times root 2 over root 2. So the one at the top is 4 times root 2, which is 4 root 2. And the one at the bottom is 2 times 2, which is root 4. So we have 4 root 2 over square root of 4, which is 2. And when you divide, you have 2 root 2 as your final answer to that. And then there's another kind of radical that we can be has to simplify. Like you have 4 plus root 3 all over 5 minus root 3. So here we rationalize by using the conjugate of this, which is opposite. Opposite is going to be plus. So that means 4 plus root 3 over 5 minus root 3 times the opposite of this, which is 5 plus root 3 over 5 plus root 3. So here now we multiply these ones here. For here, this is difference of 2 squares. A minus b into a plus b, right?
Yes.
So the one at the top, 4 times all of this, That 4 times 5 is 20, and 4 times root 3 is 4 root 3. Then root 3 times all of this. That will be root 3 times 5, that is 5 root 3. And root 3 times root 3 is root 9. You understand?
Yes.
Then this will be, so whenever you have the square, the difference between square, you square this one, which is 5 squared, which is 25. Then you square the other one, which is root 3 times root 3, which is root 9. Then we have to add this together, and this is going to be 3. So 20 plus 3 is 23. Then 4 root 3 plus 5 root 3, that will be 9 root 3 all over 25 minus 3. So 25 minus 3 is 22, right?
Yes.
So we have 23 plus 9 root 3 all over 22. So this will be the answer to that. Is that clear?
Yes.
Okay. Now let's look at another one. Maybe you want to simplify the square root of x squared plus 10x, x squared plus 10x plus 25. Now this is a quadratic expression, right?
Yes, and
So we just have to follow the, and if we look at it, it looks more like a perfect square, So we can say two numbers to multiply to give us 25 and to add to give us 10, that's 5 and 5. So we have x squared plus 5x plus another 5x plus 25 still into the root. So we have this equal to, then we can factorize x into x plus 5, then plus 5 into x plus 5. So we have the same thing here, which is x plus 5 twice, like x plus 5 squared, right?
yeah.
X plus 5 into x plus 5. So this could be x plus 5 all squared. And if we get this, we can get the absolute value of x plus 5, okay?
Okay.
X plus 5. That's the answer. Okay, we have another one to look at. If we have square root of 36, obviously that is 6 with an absolute value of principal root 6. But if we have something like square root of minus 49, so here we have to split this into square root of negative 1 times square root of 49. And square root of negative 1 is I, okay? It's a complex number, so when I say I times 7, so the answer is 7i. Then number 4, let's say we have square root of minus 64. So obviously this is going to be minus 1 and 64, and this will be I times 8, which is 8i. Yeah. So if we have, let's say we have square root of minus 25, so we're following the same step. Minus 1 times 25. So we have I times 5, which is 5i. Very good. Okay, now let's say we have this one, square root of 18. We look for the perfect square in 18. That is 9 times 2. So the answer will be 3 root 2, because the square root of 9 is 3. And this one, 48. we have to find the perfect square in 48, which is 16 times 3 is 48. So square root of 16 is 4. Then you have root 3. That's clear, right?
Mm.
Okay. Now let's consider 8. Let's assume you have 8 root 80. So we're going to look for perfect square in 80 because 80 is already outside. So we have 16 times 5 is 80. So square root of 16 is 4. So 8 times 4, then root 5. So the answer is 32 root 5. Then the next one, 5 root 98. We have 5 into the root of 49 times 2. And square root of 49 is 7. We have 5 times 7 root 2, which is 35 root 2. Okay, still on rationalization, we have 5 over root 2. So this will be what? 5 over root 2 times root 2 over root 2, right? And this will be 5 root 2 at the top, then root 4 at the bottom, which is 5 root 2 over 2. Is that clear?
Yeah.
Okay. And this one, 8 over root 3, so it's still the same thing. We say 8 over root 3 times root 3 over root 3. So this will be 8 root 3 over root 9, and that will be 8 root 3 over 3. Then the next one we have 7 over root 5. So this could be 7 over root 5 times root 5 over root 5. So 7 times root 5 is 75. Then root 5 times root 5 is root 25. So you have 7 root 5 over 5. Okay, I think we can be given another one that's a long expression, like number 13. If we have something like 4 root 8 plus 3 root 50 minus 6 root 32. Can you hear me clearly?
I can.
Okay, so this is going to be 4 into 4 times 2 plus 3 into 25 times 2 minus 6 into 16 times 2. So here 4 times 2 root 2 because square root of 4 is 2, then 3 times 5 root 2, then minus 6 times 4 root 2. So 4 times 2 is 8 root 2, then we have 15 root 2 minus 24 root 2. So 8 root 2 plus 15 root 2 is 23 root 2, then minus 24 root 2. That's good because 23 minus 24 is negative 1, so that is negative 1 root 2. Is that clear?
Yes.
Okay, I'm going to give some time to jot down the necessary points from each of the pages, okay?
Okay.
So once you're through, then I'll give you maybe one question or two to try.
Okay.
Alright. Alright, so I'm going to give you class now. Class work. Let's see. Question 1. Want to simplify 7 root 27 plus 3 root 12 minus 5 root 48. And number 2, simplify, let's say 8 over 3 minus root 2. In number 3, you have 3 plus root 2 over 5 minus root 2. Yeah, so you do the 3 questions, okay?
Okay.
Okay, so let's see the solution together. The first one says simplify this. Oh, you didn't show your steps, right?
No, it's at like the bottom.
Okay, I thought, yeah, send it. 9 times 3, yes, and root 3, 21, then check it step by step. This is 4 times 3, this is 16 times 3, so this is 4 times 5, this is 2 times 3, and this is 6. 21 plus 627 minus 20 is correct. Then the next one is to rationalize by multiplying 3 plus root 2. So 8 times this as 24, then 8 root 2, and we have the one at the bottom, which is going to be 9 and 2. 9 minus 2 is 7. So we got this. And the last one we have to multiply by 5 plus root 2. So plus root 2, 3 times 5 is 15, then 3 times, that's 3 root 2, and 5 root 2, that's 8 root 2. Wait, it's okay, plus 2, that's 17. Then the one at the bottom, 25 minus 2, that's 23. That's correct. So before we go, let's look at one question, okay?
Okay.
This question says to find the square root of x raised to the power 5. There are two ways we can do this. Let's see. The first method is to say solution 1. We can say x raised to the power 5 is the same thing as x times x times x times x times x into the root, right?
Oh.
So since we're finding the square roots, you can choose to put 2, or even if you don't put it, it's still the same thing. So now you can say this is equal to, we have x times x, like x squared, so we have x squared, then times another x squared, then times a single x. So if we split this, we can say this is x squared times x squared, then times root x. And since this is repeated, then the answer to this one is x squared, then the last root x. Is that clear?
Yeah.
Alternatively, like I said, there are two methods. So method 2, we can say, because we're finding square root of x raised to the power 5, we'll just say, okay, how many times does 2 go in 5? That is 2 times, so that gives us x squared. Then it remains only one time, which is x squared root x, which is the same thing as this, okay?
Okay.
Yeah, you can see this second method is very fast, right?
Yeah.
Okay, when we meet by the grace of God, we're going to look into more questions that look like this, okay?
Okay.
All right, your resume is good tomorrow, so I'm going to discuss with mom to know when and when we're supposed to meet next.
Okay.
So goodbye for now.
Okay, thanks so much. Bye.
Thank you. Bye. All right, viewers, thanks so much for watching and subscribe to this channel. Goodbye for now.